So for the mathematical problem, a wastewater treatment facility use a large conical tank with a height of 6 meters and a base radius of 3 meters to temporarily store water before releasing it. Due to pumping operation, the water level inside the tank is dropping steadily. At a certain moment, the depth of water is 4 meters and the depth is decreasing at a rate of 0.2 meters per minute. Engineers want to know how quickly the volume of water is reducing at that instant to ensure that downstream processing units are not overloaded. Question. Have two questions, which is first is calculate the rate at which the volume of water is decreasing when the water depth is 4 meters. Second, based on your result in the part A, give a simple opinion on whether the tank drain faster when it is full or when it almost empty. Explain briefly why.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rafiq bin Khairnizam, matrix number AA251559, and I will be explaining question 1.1. First off, for the question 1.1, for the first question, it requires us to calculate the rate at which the volume of water is decreasing when the water depth is 4 meters. So first off, we have a few information to extract from the question. First off is the height, which is 6 meters, and the base radius r, which is 3 meters, and this will be useful to find the volume of the cone. Here we have the formula for the volume of cone, which is V equals 1/3 times pi times r square times h. And therefore here we can see that this formula has two variables, which is r and h, and if we wanted to calculate easier, we have to just transform it into only one variable. So here we can see that we do a bit of calculations and we transform r into h/2, and therefore we subtract where we insert this value into the formula again, and we get this, which is V equals pi times h cubic over 12. So we differentiate it and we get dV over dt, and after we get the formula, we insert the information, which is h equals 4 into the formula, along with dH over dt, which is already given in the question below, when they say that we have to calculate the rate at which the volume of water is decreasing when the water depth is 4 meters. And at the question above, we see that when the water depth is 4 meters, the dH dt is 0.2. So we take that from the question and we insert it into the formula, and we get the final answer, which is negative 2.5133 meter cubic over minutes. So for the second question, based on your result in part A, we have to give a simple opinion on whether the tank drains faster when it is full or when it is almost empty. So for this question, the tank drains faster when it is full because, according to the formula, which is dV over dt over here, we can see that dV over dt is directly proportional to h square. This means that when water height, which is h2, increases, the change of volume of water, dV dt, also increases. That's all for me. Moving on to the second question.
Okay, this question is about finding the maximum tension in a bridge cable. The force is given by the function x equal to 200x minus 5x squared, where x is the distance from the midpoint. Because the x squared term is negative, the graph opens downward, so the maximum value is at the vertex. Using the vertex formula, we get x equal to 20 meters. Substitute it into the equation and we get the maximum force is 2000 newtons. From the graph, we can see the peak at the point 20 and 2000. So the maximum tension occurs 20 meters from the midpoint.
Next, we talk about discussion and conclusion. Both problems shows that differentiation is very important in engineering. In the conical tank problem, related rates help us find how fast the water volume is decreasing when the water level is changes. By linking the height and radius, we can calculate the exact draining rate. This helps engineers control the pumping system and avoid water overflow. In the bridge cable problem, differentiation helps find the point where the tension is the highest. By taking the derivative of the force function, we can identify the location of maximum stress. This allows engineers to make sure the cable is strong enough to handle the load safely. Overall, differentiation helps us understand changes and find important values needed in engineering design. In conclusion, both problems shows how useful differentiation is. The conical tank problem uses related rates to measure volume change, while the bridge cable problem uses derivatives to find maximum tension. These techniques help engineers make better decisions and design safer systems. Differentiation is an important tool for solving the real engineering problems.